Hello everybody. As you see here, we have this graph which is named parabola graph. This graph is the simplest form of parabola. Before we start to talk about the general form, we need to know some elements like this point, which is named the vertex point, the vertex. Its coordinate here, 0, 0. And this line help to get the other branch of the graph if we know one branch, because this is a symmetric axis, which means the two branches on both sides of this line are symmetry to each other. When we know to write the equation of vertex for the parabola, we need to write the general form for this equation. To write the equation of vertex of parabola, we need to know at least the vertex point, which we can refer to it by the symbols like H and K or any other symbols. So this H and K refers to the vertex point on this graph. And we got any general point like X, and this any general point. And we start first to look what's the value of A in this form. The general form is y equal A multiplied by x minus h squared plus k. First, we need to find the value of A by making substitution about k and h, and the general point we take here like any point, 1, 1 or 2, 4, and any point on the graph. So if we take like 1, 1 instead of x and y, so here 1 is equal A, and 1 instead of x also, minus h and k are the vertex point, which is here 0 and 0. So we write 0 instead of h and 0 instead of k, and a square here. Then we got A. Here 1 is equal to this, and inside the brackets is 1. 1 minus 0, that's mean 1. 1 squared, that's mean 1 also, times A, that's mean A. Plus 0, that's mean A is equal 1. As we got A, so we got the general equation for the graph here is equal 1 times x minus 0 squared plus 0. That's mean y is equal x squared. This is the simplest form of the equation of parabola, which refers to the parabola, its vertex on the origin point here. Okay, another example in how to write the equation of vertex. If we have the vertex point is 2 and minus 1, and any point on the graph is like 3 and 2. And we need to write the vertex equation of the parabola. Here we said this can be considered h, and this is k. So the first coordinate is h, second coordinate is k, and we start to write the general form, which is y is equal a times x minus h squared plus k. Then we make substitution about these symbols to find the value of a. Y is considered as 2. X is 3. H is 2 also. Square is here, plus k is minus 1. And here we have a, 1, that's mean a. Plus times minus 1, that's mean minus 1. So we got a is equal minus 1 transferred to other side, so it will be 2 plus 1, that's mean 3. As we got a, we can write the equation. And k, which is the same. So the vertex equation for the parabola. Now about the shape of the graph. What the effect of the change of a in shaping the graph? Let us look on these different graphs. Consider this graph here. Shape here. We see the vertex point is this point. What's the coordinate for it? Coordinates for it is 3 for x and 1 for y. So it's a 3 and 1. The vertex point is 3 and 1. Or the symmetric axis of symmetry. What's the equation for this? As it is parallel to y, so we refer to any line parallel to axis y by its x coordinate. So the coordinate is here is a 3, so the equation for this is x is equal to 3. We know other point on the graph. You can choose any point. Write the equation as we did in the previous example. See here, as the graph open upward, that means a is positive. But when a is negative, what the shape of the graph? It will be downward, open to downward. I'll show you the next graph. You see this graph, it's open downward because a is negative in this graph. So when we study the equation of parabola, we have to know exactly a is negative or positive to make sure we draw the graph correctly. When see another graphs in different cases now. These two shapes referring to graph of parabola, but in different cases. What's that cases? It's where this is or axis of symmetry is parallel to the x-axis as here, or it's the same x-axis as here. You see the shape of the graph, so it is opened towards the positive direction of x-axis. Also this in case of a is positive. And in case of a is negative, it will be opened towards the negative side of x-axis. So still the value of a affect the direction of open for the graph we draw. Not only this, but also the value of a itself. If the value of a, the absolute value I mean, not the sign, whatever the sign, negative or positive, just affect the direction where the graph open, either upwards or downwards or right side of x I mean, or left side of x. For this graph, we see the symmetric line is y is equal 0, this line. And the vertex point is 0, 0. So the equation will be written as x is equal y squared in simplest form. You see, in the previous shape, when we draw it like this way, we wrote the equation y is equal x squared in the simplest form. You see the difference here? Y is equal x squared for this shape, but for this shape, we write x is equal y squared as we switch x and y together. Let us get this note about the value of a when it is positive. In case a is positive, we see here its value affect the shape of the graph, because when it is positive and bigger than 1, the branches of the graph are very close from each other. As a increased, the value of the graph branches coming closer and closer. As a getting the value is equal 1, so we get the branches, the red color here, getting far from each other. And also as long as a coming smaller than 1, but not negative, still positive as I said. It's smaller than 1, the branches getting far and far from each other, the green branches. You see here? So the shape of the graph affected by the value of a. Let us see now when a is negative. When a is negative, we got the same notice, but the shape will be downward, will be open downward, like this shape here. When a is more than here, this shape, you see it's open downward because a is negative. But also it depends on the value of the absolute value of a. If it is less than 1, so the branches will go far from each other. And when the absolute value is greater than 1, the branches will come close to each other. This is the same as in the case of a is positive. So be careful about these notes when you study the graph of parabola. Let us discuss this example. Given that the graph, you see, which is a graph of parabola, as you see, write the equation of vertex form and equation of axes of symmetry. The main thing we have to start with is to determine the coordinates of the vertex point and any other point on the graph. They already given to us. Here the vertex point, and here's any point on the graph. So we just make substitution in the general form from these 2 points. As we know, y is equal a times x minus h squared plus k, where x and y are the coordinates for the points 1 and 18, which is given on the graph. And h and k are the points, the coordinates for the point, I mean, the vertex point, which is 2 and 20. So we start to make substitution from these values in the general form here. We got, according to this, instead of y, we put 18. Here's 18. A is still unknown. We write A. Instead of x, we write 1. Minus, instead of h here, which is 2, and squared, plus k. K is 20. By this way, we can get the value of A. Here's 18 is equal, what's inside the brackets? 1 minus 2, that's mean minus 1. Minus squared, that's mean 1. 1 times A, that's mean A. Plus 20. This will give me A. A will be 18 minus 20. That's mean it is minus 2. So A is minus 2. And we expect it will be a negative because, as you see, the graph opened downward. So it will be minus. A will be minus. After then, we return again to the same equation we started with and put the value of A here, and the values of h and k, we put them, and we keep y and x in the form of the equation. So we will get this answer. Y is equal minus 2 times x minus h. H also, it's the same point, which is 2 squared plus 20. And this is the equation they wanted me to write. Okay? It is the equation of the graph they given to me. I hope you understood. See you again in the next video very soon. Bye-bye now.